Okay, so let's take a look at using some of our settings to adjust the actual image quality. So I'm going to open up a new scene in here. And this guy is just this simple model, and it's got some different textures assigned to it. And I'm going to use this to help pick apart some of the different artifacting that you get in your rendering and how to fine-tune that stuff. I think overall what you'll find with Mental Ray is that it tends to be very, very stable, and you get repeated artifacts. And what you're really learning when you learn Mental Ray is how to tune those artifacts out. Very rarely do you get surfaces that have flashing shadows and that kind of thing. What you might get is grainy shadows, for example. So how do you tune that out? You might get jagged edges. How do you tune that out? You might get splotchy final gather or global illumination. So how do you tune that out? Maybe the scene is crashing because of memory allocation and you're trying to use displacement and you can't get it to work and you got to tune that out. So it's always about figuring out what the particular artifact is and then how to tune that stuff up. And one of the first most important things to get into outside of the memory allocation is how to adjust the actual image quality that's finally resulted. So I'm going to go into my default set or my render dialog, and I'm just going to tell it to load my initial settings, and I'll go on ahead and just render out a quick set of these images. So first thing I'll point out to you is that some of these textures are a little bit ugly, and that's because we're going to be using the scene in a little bit to talk about motion blur, and that's why I have incandescence set so that I can get some nice motion blur stuff. What I want to focus on right now is this area of this object, and I want to point out that this might have seemed to render a little bit slow, and that was because we were using a texture that is almost all procedural. So I'm just going to go on ahead and map out this texture. Here we go, this chariot texture. I'm going to tell it to map the shading network. And basically you can see that the whole thing has been built out of procedurals. And I just did that to show you that, number one, you can use layered texturing, which we'll get into in depth on disk 2. And also, they render very nicely inside of Mental Ray because it's just sitting there refining these calculations. So theoretically, there is no limit to whatever the resolution that could be displayed in here. But the flip side of that is they render a little bit slower. So this texture on the chariot is being derived via procedurals. Now, if I open up my render globals, I can turn on my render diagnostics and I can start figuring out how it's going through here and sampling this surface and then resulting in the shading. So if I go to diagnostics and I turn on diagnose samples, it's going to show me how it's building the anti-aliasing and how it's subdividing. And you've basically got a couple of different settings in here. I'm just going to render one small area of this. You've got a couple of different settings in here. One of them is the minimum maximum samples. So as your scene is being considered and the shader data is being generated, it has to either subsample or supersample. And by setting this to -2, we're allowing it to subsample. So for every, for example, every 2 shaded points within the scene, it can use 1 sample as opposed to 0, which would cause us to sample every single point, or 1 or 2, which would cause it to supersample the scene. Most of the time, you don't want to put a minimum number greater than 0. And the reason is, if Mental Ray can get away with just doing 1 sample per shaded point, that's a good idea to let it do that. A case that would not necessarily work so well is using something like Fur, where Fur tends to like very high render settings in order to alleviate some of the anti-aliasing problems. And at that point, you might end up using a minimum sample that's a bit higher than 0, for example, a 1 or a 2. On the flip side to that, if you wanted to, so this is going to be a good set of default render settings. -2 and 0 will deliver a nice default image that you can work with and tune your shaders and so forth. If I want to set this to a lower number than 2, Mental Ray will absolutely render that. It's going to be sacrificing image quality, but sometimes you're just trying to get compositions right or color of lighting or general texture placement, something like that. And in those cases, it can be nice to set a lower level of minimum samples because it'll just render a lot faster, enable you to previs that much faster without taking out too much time. So I'm going to leave this set to 0 and 2, and I'm going to talk about my contrast RGB settings. So if we're telling it that it's able to subsample and its maximum samples is going to be set to 0, then we're having to tell it how is it going to decide when it divides into multiple levels of samples. And that's where contrast, RGB, and A come into play. What's happening is that it's taking two shaded points and it's comparing them. And if the contrast ratio between those 2 points is greater than, in this case, 1.0 or 0.1, then it's going to force it to subdivide. And it will continue to subdivide until it works within this threshold. So the lower these numbers go, 0.05, 0.05, the more detailed that sampling is going to be, because you're saying you can only, these two shaded points have to be subdivided until their contrast threshold is to this ratio of 0.05. And the lower those numbers go, the finer the refinement of detail is going to be on the surface. So in a situation like the side of this chariot where you've got a lot of different texture variants, these numbers being set very low will continue to refine and refine and refine. Other times you'll have a whole scene where you have a blue solid in the background and there's no shading information really present there. And at that point, setting these numbers really low won't make a lot of difference because there isn't any contrast variance. So on the flip side of this, if you were going to set up your default renders for doing a production level rendering, if I just simply go to a minimum sample levels of 0 and a maximum sample levels of 2, that's going to give you a pretty nice starting default production level. It's going to deliver very smooth, nice aliased lines, and you shouldn't notice a lot of swimming in the textures. But if you have to go in and start tuning, then you can start tweaking these numbers out. So that's what I want to do. I want to take a look at what's happening when it starts subdividing. So I'm going to go to -2 and 0, and I'm going to set my contrast threshold to 1. And notice how dense this gathering of the mesh was. That was at set 0.1. Now set to 1, if I render this guy back out, you can see that the density within the contrast is barely even noticeable. We don't hardly have any samples being taken on this surface because the shader variance or the contrast variance is so great that we can have a huge amount of disparity between shaded points, and it doesn't force it to calculate down. So so this is with these settings at 1.0. If I was to start lowering these down, these samples will become more and more dense. So if I go to 0.5 and we render this guy out, you can see that the sampling regions become more and more dense. And again, if I lower this again to half, and I render this out, it becomes more and more dense. And finally, we'll get to our initial settings, which were 0.1. And you can see that it just continues to resolve and resolve and resolve. So one of the artifacts that you will sometimes get within your scene is that the textures will appear to swim. If you have very detailed textures, for example, maybe you're rendering a brick wall that's a small area within the scene, so there's a lot of detail that's been stacked into a small portion of the scene. Sometimes you'll need to lower these contrast values lower than 0.1 to alleviate some of that texture swimming. Initially, what you should do to get rid of that texture swimming, for example, is to set yourself to a production level of settings of 0 and 2. And after that, if the swimming persists, then you start moving these numbers down. Now, the reason that you can move RGB and A independent of each other is sometimes you'll have more contrast in a certain color spectrum than you will in another. For example, this scene has got a lot of blue light, or it's got a small amount of red light. So maybe I want it to be more sensitive to the blue shift than I do to the red shift or the green shift. And by lowering those numbers down, I'll force it to compare contrasts on a much tighter level of detail for blue than I do for the rest of the scene. So it's just a way of helping you tune individual parts of the scene as you go. Underneath sample options, you'll notice you've got two new settings called sample lock and jitter. Sample lock is going to force the mental to sample the same exact shaded points every single time that it generates an image. Sometimes you'll have problem with roping or swimming within your image, and you can't seem to alleviate it anyway, and by telling it to sample lock, it'll force it to have consistent sample regions throughout, and it should alleviate some of those problems. On the flip side of that, sometimes you'll have color banding, like you'll get big chunks of color that seem to pop within the scene. For example, you have a gradation in the sky that has very little color shift. Maybe you're just doing a soft blue in the sky and you don't shift very much in the color spectrum, and you get those poppings. Now, forcing it to jitter would be telling it to systematically alter up the samples that it's taking per frame or per shaded point gather, and that should help alleviate some of those problems as well. So again, for my contrast settings to be on production, if I set this to 0 and 2, and I set my I'm just going to turn diagnostics off, and I'm going to turn my contrast RGB A to 1.0, and I'll try and render that out. I think one thing you'll notice is that adjusting those production level settings up is going to be a lot more expensive in terms of the render, but it also smooths everything out. Now, there are some things that are happening here. For example, I can see tessellation in here. I can see sharp corners in these geometries where I know they should be smooth, and that's because it's a NURBS object and it's being pushed over into polygon land, and it's not doing so with enough facets, so it's creating some tessellation errors, which we'll talk about here in just a minute. But other than that, the textures look pretty solid, and I don't have any aliased edges. Everything looks pretty nice. So you'll see that these initial settings of 0 and 2 look pretty nice. Now, the only other thing that we might want to consider as we're rendering this stuff out is that once the shaded information is generated, it has to be combined into some sort of resulted pixel. And that pixel will be filtered, and depending on the level of filtration and the kind of filtration that is applied, it'll vary the softness of the image. And Box, this sort of steps from lowest quality sampling or lowest quality filtering to the highest quality filtering, if you can think of it like that. Box is going to be the softest, and Langhaus is going to be the sharpest, with all these different divisions in the middle. Personally, when I do a production level rendering, I usually set this to Mitchell. And I have great luck with those render settings. If you're doing a non-production level rendering, like a -2 and a 0 for minimum maximum samples, Mentor will automatically force it to sample up to a lower level of filter anyway, but setting it to something like Box will probably help that out. So again, all this information that's generated as the information is being shaded has to be combined into pixels, and these settings are going to help decide the quality of that resulting image.